Example 7. Find the function that is finally graphed after each of the following transformations is applied to the graph of y equals the absolute value of x in the order stated. First, shift left 2 units. Next, shift up 3 units. Finally, reflect about the y-axis. All right, so the basic function here is the absolute value of x, and you have to perform these 3 transformations in the given order, and you need to come up with the equation that does this, okay? I am actually going to do this, okay? I'm actually going to kind of sketch a graph of what this thing is going to look like, okay? That way, once I come up with my equation, I can go to my calculator and compare the equation I came up with to the graph, okay, to see if I'm right. Okay, so let's think about this. All right, so let's see. Hang on, let me move this thing. All right, so here we go. We've got this axis like this, and let's do what it says. Okay, so we know absolute value is the V shape. Okay, so if, let's see, here's the original function. Okay, so it's going to be like, well, let me put it in black. Let's label our points here. Okay, I'm going to take basically 3 points from the absolute value graph and try to move that. Okay, so originally we know that the absolute value function is a V shape. It goes through the origin, it goes through 1, 1, and it goes through negative 1, 1. Okay, so I'm just going to do this little portion of the graph, okay, and transform it to help myself kind of reason through this. All right, the first thing we need to do is shift left 2 units. Okay, so this vertex here is going to go to the left 1, 2 units. Okay, so that's going to bring me here to negative 2. Okay, so then all these other points, the other 2 points have to shift left 2 units. So 1, 2. This guy's going to go over 1, 2. So it actually ends up here at negative 1, 1. Okay, so that's going to be what you get after you shift left 2 units. Okay, so now we need to go up 3 units. Okay, so again, I will take my vertex and move it up. Okay, so I'll put this one in green. So let's see, negative 2, 0 will go up 1, 2, 3 to negative 2, 3. Okay, this guy, if you move it up 1, 2, 3, okay, that's going to go to negative 1, 4. Okay, if you move the point at negative 3, 1 up 3 units, 1, 2, 3 right here, it'll go right here to negative 3, 4. Okay, so I'd get this. Okay, and like I said, I am just trying to give myself an idea of what this thing is going to look like. Okay, the last thing I need to do is take the green part and reflect it over the y-axis. Okay, so this should be kind of simple to do because we can just, use our symmetry rules. We've got, let's see here, our green points here are negative 3, 4, and then negative 2, 3, and then negative 1, 4. We know that if we reflect them over the y-axis, okay, if you have y-axis symmetry, that means you're going to keep the y value the same and you're going to change the x coordinate. Okay, so negative 3, 4 is going to go to 3, 4 because we changed the sign of the x value and we keep the y value the same. Negative 2, 3 is going to go to 2, 3. And then negative 1, 4 is going to go to 1, 4. Okay, so that will be the final positioning of the graph here. Okay, so I'm going to go ahead and sketch out these points and then we'll try to come up with the equation. Okay, all right, so here we go. Let's see, we will plot these points. We're going to have 3, 4, that's right here. Okay, and then 2, 3, that is going to be right here. And then 1, 4. Okay, so this is just a little portion of the final absolute value graph that we're trying to come up with. Okay, once we come up with our equation, we can plug it into the calculator and see if it matches this portion of the orange graph. Okay, all right, so Let's go back. The original function here is graphed in black. So we're starting with the absolute value of x. The first thing we did was shift it left 2 units, okay? So if you're doing a horizontal shift, that means you have to add or subtract inside the parentheses. So that means add or subtract inside the absolute value symbols in this situation. Okay, so let me take this off. Let me move it over. So since we are moving to the left, we need to add. Okay, so we're going to moving to the left means you add, and we're going to be adding 2 because that's how many units we're going left. Okay, so that should give us the red graph. Okay, now we want to get to the green graph, so you have to go up 3 units if that's a vertical shift. So you're going to add outside of the parentheses or the absolute value symbols here. Okay, so this should give us the green graph. Okay, the last thing we need to do is reflect over the y-axis to get the orange graph. Okay, so remember, what do you do in the case of a reflection? So let's go back to our reflection rules. If we're reflecting over the y-axis, you have to put the negative sign on the x in the inside. So inside parentheses, here inside absolute value. Okay, so I would go to my equation, and inside the absolute value, I'm going to put a negative sign on the x. Okay, so this should be your equation. Okay, let me write it a little better. It's going to be the absolute value of negative x plus 2, close absolute value, plus 3. Okay, let's go to the calculator, punch this in, okay, and see if, the part around the V, the part with the sharp corner, if it matches these points, 3, 4, 2, 3, and 1, 4. Okay, so let's go check it out. This will also be useful because you're going to learn how to put absolute value in your calculator. Okay, that can really help with transformations. So we're going to go to y equals to graph this thing, and we need to call up the absolute value function. So to do that, you want to locate the math button on your calculator. So here's the math button, and you want to go over to the number menu. I just used my arrows to do that so you can see what I did. I just did this. And this option 1, ABS, that's absolute value. So hit that, okay? And you can see it brings up the absolute value symbols, okay? Well, what did we put inside of our absolute value symbols? Well, we had negative x plus 2. So negative x plus 2. And then outside of the absolute value symbols, we had plus 3, okay? So this is how you're going to enter it in. Okay, so hit graph. And let me see here. I need to maybe adjust my window. Let me see here. Yeah, I think I need to adjust my window, okay, because we need to see more of the y-axis. So let's go to our window. I'm just going to go back to the standard window. If you don't know what something looks like, you go to -10 to 10 in all directions with a tick mark of 1 unit. So like this. And then hopefully we can see a good picture. There we go. Okay, so let's see if this matches the orange sketch we did. Okay, so I'm going to check to see if 3, 4 is on the graph. Okay, so here's how you do that. You do second trace or second calculate, brings up this menu. You hit option 1, it's going to give you the value at a certain x value. Okay, so if x is 3, the y value is 4. Okay, so see what I did? I punched in, what's going on at x equals 3, and it tells me the y value, and it even highlights the point on the picture. Okay, so that checks out. And then let's look at 2, 3. It should also be on this graph. Okay, so let's do second trace or second calculate. Follow my cursor here. We're going to calculate, hit option 1 to calculate the value. We're going to look at what's happening at x equals 2. Okay, 2, 3 is on the curve. Okay, going back to my notes here, there it is, 2, 3. And then lastly, I'll check for the third point, 1, 4. Is it on there? So again, second calculate, second trace, however you want to look at it. Option 1, what's going on at x equals 1? Hit enter. We get a y value of 4. So you can see the 0.14 is on the graph here. So it looks like we are indeed correct. Okay, this equation, the absolute value of negative x plus 2, close absolute value plus 3, gives us the graph of the absolute value function with these three specific transformations applied in this order.